My name's Matt Seymour. I work for HPE Point Next, which is the advisory and professional services wing of HPE. I'm part of the UK network delivery team, so I travel around the country helping people build networks, which is quite good fun. But I spend a lot of time in higher education, and so when invited to come and contribute something today, I thought that's something I can talk about with, I sort of kind of sound like I know what I'm talking about anyway. Of course, this is just my opinion. You can disagree with everything I say here and tell me later. Please no heckling. I don't cope with that. Now, I think universities are one of the best places to learn Wi-Fi, not just because that's where I did, but because there's just huge variety. There's a bit too much variety. There's a heck of a lot going on, and it can be really difficult to kind of contain that and turn it into something you can manage. Now, the first thing to understand on a university campus is just how important connectivity is. I know this goes without saying, and we make jokes about the place of Wi-Fi in Maslow's hierarchy of needs, don't we? About how it's slightly more important than oxygen. And just a little story. I was in a halls of residence a few years ago, and there'd been a catastrophic plumbing failure. And for some reason, they'd put most of the big water tanks on the top floor, and water was cascading down the internal walls and over the network equipment, which was still working at this point, but it was also coming across the 400-volt mains incomer. So we didn't think this was a good idea, and isolated the building. Someone else went and turned off the water. And at this point, this guy comes out of his room and barefoot, squelches along the carpet a bit. There was a lot of water. Phone in hand, is the Wi-Fi down? Now, this was at the University of York, which is where I spent a good number of years. It's a really lovely campus, built in the 60s, just outside the city centre. And because it was built in the 60s, you get a lot of concrete and a bit of brutalist architecture, like this spaceship thing here, and more concrete behind there. Now, those buildings, these ones over here, they're called CLASP, and they're really interesting, I think. So we'll come back to those in a bit. But as well as the 60s stuff, we've got a fancy country manor, originally Tudor. This is Heslington Hall. It's where the university started, mostly 19th century. They don't care about it too much, but there are some very interesting thick walls and some very thin floors. It's challenging. There's brand new buildings, really exciting things. The kind of place where absolutely nothing is straight, but it's supposed to be that way, and that presents all kinds of aesthetic challenges because the architects don't like anything interrupting their line. Then we've got other buildings where absolutely nothing is straight for different reasons. This is the King's Manor in the centre of York, and this was 11th century abbot's residence originally, and then it became the seat of the Council of the North under Henry VIII. It's so old you can only represent it in black and white, and actually if you want to drill holes in it, people get very upset with you. The discussions about renewing the fibre connection into this building lasted 18 months. It's interesting. And then you've got a load of stuff that was chucked up in the 80s and 90s, and it's deeply uninspiring. But all of this means you've got a huge variety, and you need to try and contain that in some way. Now, when we're talking about Wi-Fi design, and we've heard about all of this already this morning, requirements, kind of key. It comes down to which devices need to do what and where, really, doesn't it? I'm getting a nod from Keith Parsons. Now, you will not get that information in a higher ed environment. You just won't. And if you do get it, someone else will disagree with that and it will be wrong. So what do you do? And why is that? Well, the first problem you've got is you have zero control over the client devices. They can be literally anything. It's the ultimate BYOD environment, always has been. Students bring stuff. They expect it to work. And we're used to this phrase, the most important and least capable. So the idea is we have a device, and the example always used to be the CEO's BlackBerry, long after BlackBerries had died, and that people really wanted that physical keyboard for a bit longer. I don't think that's the example used anymore. But the problem with this idea is that we haven't got a CEO, we haven't got a device we can really latch onto. So where do you start? I say we've got no CEO, but we do have a Vice-Chancellor, and if they've got network problems, then, well, we probably do want to make that a priority to deal with. But genuinely, on a university campus, it is about everybody. And the reason it's about everybody is that every student is invited to fill in a national student survey every year. And the participation in that is high. And that comes down to an aggregate score that's applied to the institution. And so when students are looking for, or prospective students are looking for where they might go to university, which is a hell of an investment, that score matters. And it has an impact on how many people want to come and study at your university. So if your Wi-Fi is rubbish, and we've already heard that that kind of matters more than water, it really does have an effect. You also have the problem of the high-profile academic and their prestigious research and the prestigious research grants that come with it. If they don't feel they're being adequately supported by the work that you are doing, well, they can take their prestigious research and the grants and they can go down the road to another institution that will promise them more. So this has real-world implications, but we can't pin it down to one important person. So what is our most important, least capable device? Is it a cheap Chromebook? There's lots of those. Raspberry Pi, that's a lot of those, and it's quite a quantifiable thing. We've got cheap smartphones. There's some absolute horror shows out there. It's quite interesting, especially from overseas students. It's a while since I checked. Certainly about 18 months ago, you could still buy a brand new laptop from Currys with 2.4 gig only. And students were turning up with those. It's not ideal, but it is what it is. And so what you realise is we can't pin it down to a device. Never been able to do that. What we have been able to do is say, well, what is our RF design target? Who here designs for Neg 67? Quick show of hands. Okay, not as many hands as I expected there. Well, what I found was targeting Neg 60 in Ekahau works in this environment. If you go for Neg 67, you deploy that, you validate it with the sidekick, you get your Neg 67, happy days. So you then imply maybe your 10 dB offset. Oh, it's not looking quite so good. And then we've got some really pants devices, and they're not 10 dB worse than the sidekick, they're worse than that. And so suddenly they're having a bad time. Targeting Neg 60 works well, in my experience. So then we come to the user requirements and expectations, and there is a lot of expectations. And this is one of the reasons why it's really hard to pin things down. But it's too big. You know, we've got too many variables here, and we need to try and sort of contain this monster, get it into a box somehow. And I found that if you think about who the users are and where they are, and what patterns of behavior you can see, you can then turn that into requirements. And it's actually quite simple in my view. Feel free to disagree with this. So first of all, you look at students. That's our biggest contingent of users. And we have them in, say, 3 distinct spaces. And a user's requirement in different spaces is different. So students in study bedrooms, they're home from home, is different from when they're in a shared study space like the library, is different from when they're in the lecture theatre, a room like this. Then we've got an admin staff. Well, admin staff are often tied to a desk. They're often using a desktop PC. They might not be moving around at all. When they do, they're going to a meeting, a bit of Google Docs, maybe they're working in the cafeteria. And then we have researchers, and by this I mean somebody who is requiring something specific of the network, as opposed to someone who is just a researcher working on whatever. And I've distilled this down to these 4 categories, kind of 4.5. Admin is our baseline. So admin is laptop, tablet, low bandwidth use. They're not demanding a lot of the network, they just expect it to be there. This is actually the majority of users most of the time on the campus. Domestic is our student in their study bedroom. This is where you're an ISP to thousands of people living on campus. And it's high bandwidth because what are they doing? Streaming, gaming, multiple devices. The expectations are high. And this is also where you'll see kind of weird stuff coming in, like particularly every January, you'll have a huge spike of help desk calls because people got stuff for Christmas and they bring it back and then you have to try and make it work or agree that you're not going to. Research is home of what the hell is that? Anything goes. It could be who knows what, you know. We've got some ancient Android version on a bit of lab kit that has never and will never get updated. A swarm of autonomous robots running a real-time operating system that's completely custom and doesn't support anything very much. Raspberry Pi on the roof counting bees. Sometimes it's not that what they're doing is particularly unusual, but it might be where they're doing it. I remember having to support a really interesting project that was taking soil samples at the far side of campus. Absolutely no connectivity, so we then had to start working on point-to-point links and adding extra capabilities in for that. High density, I actually split into two, numbers and/or throughput. And what I mean by that is that you will have spaces where you have a lot of people, but they're not doing very much. So it's all about supporting the client count, but it's low airtime. The study spaces are a good example of that. The library can get incredibly busy, especially around Easter, running up to exams. And you need to support that many clients in that space, but they're not doing much. Maybe a bit of streaming for buffered services like Spotify, bit of Google Docs. Airtime is almost universally low in these spaces because people are studying. And things change. So here's a library. I'm sure we've seen these. Those shelves are fun because they're metal, about, 3 foot thick? Well, metal and wood. They're pretty solid barriers to RF. And to be honest, we never really tried covering in between the shelves, partly because we didn't need to, no one was asking for it, and also it was hard. Fine. But in response to demand, these shelves all disappear and desks appear in this space, and suddenly the number of clients you need to support in this area has shot up. You probably weren't involved in that process, you now have to respond to that. And I've heard it said that academia is a bit slow and fusty. You know, business, the corporate world, that's where things are happening. In my experience, exactly the opposite is true. Academia can move incredibly fast. And particularly, back to that student survey, you want to keep people happy, you want to get a good score because that matters. You respond to what students need. So, let's look at a building. I've got a couple of examples, just two, I think, of what I think were quite interesting buildings and some challenges that we had to overcome. So the first thing about this is, does it fit into one of our categories? So is it an admin building? Is it accommodation? Is it a research facility? Well, this actually is an admin building. Fine, quite straightforward. Central corridor, rooms off each side, very simple, great. Now, I mentioned CLASP earlier, so I'll come back to that. So that stands for Consortium of Local Authority Special Projects, and it comes from 50s and 60s. I think they were still building them in the 70s as well. And essentially, it's part of our post-war building boom. It's how we were going to build municipal buildings. It's a kit of parts. So you have a concrete platform, you stick a steel frame up, you hang these kind of prefab concrete panels on it, bolt them all together. Lovely. Anyone can design it, you don't need to be an architect, makes life really easy, and it makes it cheap, and you can roll out stuff quickly. And it's a massive liability now because they're thermally disastrous, and they also have asbestos designed into the building. You don't get to remove it. You can contain it, you can clean up some of it. Yeah. They're also outside their design life of 50 years, and some of them have been listed, so they're never going to go away. It's all wonderful. So what becomes easy in a building like this, and I'm sure we've all seen it, is a bit of trunking along the corridor, APs in the corridor, and we end up with something that looks a bit like that. Ignore my channel numbers. And I mean, I know APs in the corridor isn't cool, but that looks okay, doesn't it? We reckon that'll probably work, and users will probably be happy. They don't need a lot. But there's another little treat that this building has, a material called stelvertite, which is not very common these days. Essentially, it is sheet steel wrapped in plastic and used for the walls. Specifically, these walls. And so actually what we end up with is something that looks more like that. It sucks to be in some of these offices. And lots of people have put up with that. And then what happens, you get a new generation of academics come in and go, what's this? Where's the Wi-Fi? And well, it's all in the corridor where we left it. So what we'd really like to do is something like that. So APs on ceilings in the appropriate rooms, pretty standard fare. We cannot do that because we cannot go into the ceiling void and run new cables. We can't even take our cables we've trunked along the corridor and come in through the door frame because the door frame's metal and the stelvertite walls, and when they're not metal, the door and window reveals are often made of asbestos. So essentially, you cannot run cables, you cannot drill holes without enormous cost. Marvellous. So this basically brings me on to my favourite AP form factor now, which is the hospitality or Warjack AP. So this is an Aruba AP505H. There's nothing exclusive to Aruba about these. I think all the vendors have something like this. I've spoken to people who kind of don't really get them, or they've never used them. They don't really know why we bother. These things are amazing. I love it. So you get Wi-Fi, you get a 4-port switch that you can't see on the bottom with PoE. So the benefits this brings to our asbestos-addled building are we can do this. So we can put the AP in the room. The Wi-Fi is no longer just hanging out in the corridor, chewing gum and trying to be cool. It's actually going to work. And also, often when I deployed this, we've ended up pulling out old 100 meg switches and even hubs. One academic was complaining that the network was quite slow. I'm like, well, you're running 4 PCs off a 10 meg hub. It's going to be slow. And the other big advantage as well is often these offices for one can become an office for two. We've already got some extra data points available. Here's another building. This, it's a little hard to see. I should have prepared another version, but never mind. This is a building that's 50 years newer than the last one. Essentially, it's the same design. It's a corridor up the middle, rooms off either side. Concrete floors this time. No stelvertite in here, but you will notice these kind of areas of grey despair kind of in the middle. And that comes about because of the washrooms, which are prefabbed, off-site, craned into place when the building is built. They're made of metal and concrete because they need to be nice and rigid so you can transport them. And they create an effect a bit like this. Now, in reality, they're not this bad. This is kind of a worst case model, just to kind of make the point. But you can see that if you put APs in the corridors of this building, which someone did, and you center those APs in those grey areas, which they had, you're not going to get great service in the rooms, which is where you want it. So just a couple of thoughts on requirements for this. We don't care about roaming. So even if those grey areas were as bad as that and you lost your connection, we don't care. What we care about is high performance Wi-Fi in the rooms, and that's what this gives us. Reasonably high density as well, because we end up with one AP covering 3 to 4 rooms. That tends to work nicely. Depends on the walls, but it's a decent model, and it's then a model that you can apply to multiple buildings of the same design. This is inside that spaceship thing we saw earlier. This is Central Hall, capacity about 1,200. It's used for the Church of England General Synod every other year, I think. They were setting up for it here. And anybody who's done any auditorium design might look at the lighting truss and think, oh, happy days, I can stick some directional antennas on there, that fantastic new Cisco thing that we saw earlier. Yeah, I'd put one of those and probably do it, great. Yeah, you can't put anything on that truss, they won't let you. You also can't fasten anything to any of the other metal work that's visible in this picture for reasons. And under the balcony that you can see there, for reasons nobody understands, are loads of data points that got installed. I think someone sneezed over a drawing and they just got put on. And again, using those hospitality units, I think it was the 303H we used in here. We actually just put loads of them all the way around, facing down. It's not what they're designed for, but they're a semi-directional antenna. And so those on 5 gig, running relatively low power, provide really nice contained cells all the way around the top. And then we had a few more APs underneath the seats, because these seats are kind of movable. And that worked really well. We got a really successful high density design in the space, and nobody really noticed it. So that was a good success. You've got to sense check what you do. We talked about validation earlier, and this is just to reiterate how important that is. So even if you've got really consistent structures that you're working with, you don't know what people have done in the rooms. This is a fairly average academic's office, I think, and the walls are effectively a foot thicker than you expect. And also, we tend to mount the hospitality units quite low in the room because that's where our data point comes in. So if it's low down, and you're having to go through, well, a room full of solid paper, that's going to be a problem. So it's just about making sure that we don't just chuck it in and assume it'll work, because it worked in the last building. We've still got to validate. We've still got to do that work, do it properly. It would be remiss of me not to mention these things. It's not really what we're here to talk about, but I think it is important to mention. This may sound obvious, but campus users are mobile. They move around absolutely loads. And if you don't design your network with that in mind, you can have problems. So layer 3 mobility, just don't do it. Not on a campus. I know you can do it. I know there are ways it can work, but don't. This is the reason why Wi-Fi gateways and controllers tend to be the favored approach when we're designing campus networks, because we can tunnel all the traffic to a common point in the DC, break it out there, keep a consistent layer 2 domain. And it's particularly important when you look at this nice generic photo we have here of people sitting outside on the grass, because we put external Wi-Fi to make those areas work. So we kind of fill in the air gaps you might previously have relied on. So that's just worth mentioning. Sizing the back end. Just, we know this stuff. We have to do it right, get your subnets right, can the DNS server cope? Bear in mind, universities are growing. Excepting the last 2 years, more people, a few more devices per person. You can have 5,000 more clients on your network this year than last. Can everything cope? Can your DC routing switches cope? I got burned by this once. A very big, powerful routing switch that we were using by default favors MAC table over ARC table. We filled the ARC table. That was a bad day. But I'd like to leave you with this, and I think it's probably my most important point, really. And that is, do what the users need. We can have a tendency to try and apply policy, apply standards. Say, this is our template for this building, that's how it works. This is what a user can do. We're going to control them with our network access control. We're going to lock everything down. And that's fine. And in a lot of environments, it's absolutely the right thing to be doing. I spent a long time having to kind of rebuild trust with one particular department, and they had filled the place with TP-Link routers. And it was an absolute disaster because they all still had their DHCP servers on. That was being blocked by the switches, but it meant every time you connected to Wi-Fi in a different room, you got a different subnet and then you were natted. Oh, it was an absolute nightmare. But the reason they'd done it was because they'd come to IT services and said, can we do this? And then we told them, no, we can't support that. So what do? You know, they find it a way to make it work. And actually, that way to make it work is far more of a threat to the network. It's far more damaging, and it's far harder to support. And guess ultimately who has to support it and make it work? Now, I know that the ITIL people will clutch their pearls and reach for the service catalogue, and they will say it's not in here to allow the autonomous robot to talk to the coffee machine over the Wi-Fi. We have had that request. It's quite an interesting one. But the reality is that we're not in a corporate environment where we can set a policy and go, there you go, do that. That's it. If you want to do something else, go somewhere else. They're clever people. Researchers who are working on something, the people who are in the Institute for Safe Autonomy, where they want the robot to talk to stuff, their whole world is solving problems. And are you just going to be another one? And if you just present another barrier to them, they will just navigate a way around you. So for me, I think, accepting everything else I've had to say, I think the key to good Wi-Fi design in higher ed is about getting standards in place, standardizing and templating everything you can so that when you need to have an exception to that, you are not the barrier. Thank you very much.